some recording. I have at the end of lab 5, two sets of data to sort of use for sort of demonstration purposes. So they're not marked as lab, so there's nothing that you have to do or turn into me, just some data for me to sort of play with in front of you. Okay. This first one has a little calculation and then an if. So I want to sort of demo an if. That's one of the things that takes some getting used to. Some people take right to it, but most people, it takes a little while. Okay. So here is some made up data, and it is, we measured the mass, and these were sort of, I don't know, little pieces of material, and they were like nice rectangular-ish, three-dimensional, but so they just had simple length, width, and height, and a mass. And the question is, from this information, we're supposed to determine if it will float or sink. Okay. So here we go. All right. So we need to do what? We need to figure out the density of the object, and then we're going to sink or float. We'll say we're going to put it in, I don't know, let's say seawater. And then if it's denser than seawater, it will sink. If it's less dense than seawater, it will float. Okay, so let me Google, I don't know, seawater density. There it is. Okay. Between 1.2 and 1.3 grams per centimeter cubed. So I'm going to say 1.25. All right. The first thing we need to do is to figure out the density of these objects. And so we need, the density is mass over volume. We can do it in one swoop, or we can calculate the volume and then divide the mass by the volume. So do you want to do it sort of, you want to spread it out in 2 steps, or you want to do it in 1 step? Does anybody care? Nobody's saying anything. I'm going to do it in 2 steps. So let's get a volume. And that will be in, I don't know, centimeters cubed, I'll say. And this is just a very simple shape, and the volume will be length times width times height. So I'm going to do a calculation, so it's equal. And I'm going to do the length multiplication is an asterisk star, the width times the height. And so here are that's the volume, and I'm pulling down. Okay. So there are the volumes. I had outlines around everything. Let me get outlines around everything. That's under here, under borders. Okay. So this is a, I had this A, B, C, and D were data. E was a calculation. I calculated the volume by multiplying length times width times height. Now the density, spell it right, density is going to be, comes in grams per centimeter cubed. And so that is mass over volume. So that's equal to the mass, which was an A, divided by the volume, which was an E. And enter that. And then I'm going to put myself in that cell, get down into the corner, which I call the thin cross, and pull You can also just get where you have the thin cross and double click, and it fills in. Okay, so here are some densities, and I want to say whether the densities, so now I know the densities, I want to compare them to a 1.025, I said for seawater, and then say if it floats or sinks. And this data might change. And I don't want to come here and write, oh, this is denser than water. I don't want to come here and write sink, because then somebody might come along and say, oh, this, the width wasn't 6 centimeters, it was 7 centimeters. And why did that change? There we go. Maybe it was 7.5. Now it changes. So I wanted to update based on the data. I don't want to just write words. So I want to use a formula. So remember I changed this one. So your answer, if you're working along, may be different. Okay. Now we're doing sink or float. And this is just a sort of simple example of an if. So there's a function in Excel, the if function, and you start, anytime you want Excel to do work for you, to do a calculation or figure something out, you start with an equal. And then you use the word if. Excel is not case sensitive. You could say capital IF, you could say capital I, capital F, you could say little I, little f. As far as Excel is concerned, they're all the same. That will change later in the semester. When we start doing R, which is soon, R is case sensitive. R cares about every little thing. Excel, not as much. So Excel's a little more user friendly. Okay, so equal if, and then it's a function. So we have parentheses. There are 3 parts of an if. You ask a question, that's a true or false question, and which is usually about equality or greater than or less than. And then you say what you want to do if it's true and what you want to do if it's false. And we're just going to have words, but you can also do other calculations. Okay, so we're comparing the density to 1.025. So if the density, if F2, which is our density, is greater than, what was it, 1.025, that's our seawater density. So if the object's more dense than seawater, so that is our question. So this thing with an equal or with a greater than or less than, we're asking a question. The first thing is a condition or a question, or they call it the logical test. It's something that's true or false. In this case, it happens to be false, but we want to be able to have Excel adapt. So we don't want to just go in and type in what we can see the answer is, but we want it to adjust according to the data. So we want it to be based on formulas and data. Now, all we want in this case are words, and words go in quotes. So if this thing was denser than the density of seawater, it would sink. So I'm just putting in the word sink in quotes, and that's what I want to do if it's true. If it's true that the density is greater than 1.025, I want to write the word sink. And then the third thing is what to do if it's false. And I'm going to say that if it's less dense than water, if that condition were false, you only have to ask the question once. There can be scenarios where you have 2 questions, but this scenario is just 1 question. It's simple. It either sinks or it floats in seawater. So that's a simple yes, no question. So there's one question. And so there it is, the three parts: equal, if, open parenthesis, ask a question, ask a true false question. Is the density greater than 1.025? If it is, what do I want to do? Right now, I only want to say words. I put the words in quotes. I want to say sink. What I want to do if it's false, I want to say float. And then I can get up here and copy it down. So these things that are denser than water are sinking. These things that are less dense than water are floating. And if I change the data, where was that 7.5? That was originally a 6. And it goes back to sink. So that it should update. If any of the data were to be updated, the calculation should update. And this is just basically another calculation. So that is just, so that's just one simple question. And most of the times I will be asking just one simple question. There can be multiple questions. The lab has an example of, I give you a melting point, which is the division between a solid and whether it's fluid, which could be liquid or gas. But I could give you two temperatures. I could give you a melting point and a vaporization point, or I don't know what it's called. I'd have to look it up. But then you would ask two questions. Is the temperature less than the melting point? And is it less than the other point? And then you could say whether it was solid or liquid or a gas. But we're only asking one question. So we're just hiding our ignorance and just sort of saying fluid. So we're saying gas, we're just lumping together gases and liquids together and calling them fluids because we only ask one question. But it's possible to ask two questions. That's all I'm saying at this stage. Any questions? Ifs are hard. They're not like a standard calculation. It's not, you know, multiply this and take it to the third power. It's a little more complicated. So some people struggle with it at first. Okay. I usually try to keep it simple. That wasn't too hard, I hope. All right. Let's I have another just set of data to play with for demo purposes. So where is that? Here is some demo data. Okay. Enable editing. I have two sets of data here, temperatures, and these are temperatures all around like 98. So this is some body's temperature. And you can see like maybe what the average body temperature is for this group and things like that. And then there's IQs. I think I'll play with this IQ data. I have, I think, 100 of them. And there are lots of quantities, statistical quantities that I have you work through, and they're usually pretty easy. There's just a formula and you put it in. Let me do one. Let's say like maybe the median of all of this data. So that's some measure of the middle. Okay. Now if here's a trick of sorts. If I were to copy this down, the A1 colon A100, if I copy down, becomes A2 to A101. But if I put a $sign in front of the ones, that sort of fixes those numbers so that when I copy down, those numbers don't change. So now I have, when I copy the formula median, open parenthesis, $1, colon, $100, close parenthesis. When I enter that formula, I get the same exact calculation. It doesn't adjust. So what good is that? Well, that allows me to come in and change median to average, because all of my different statistical measures are over the same set of data. So I can sort of copy down, and I'm going to change the function, but I'm not going to change the data. So I can do this overkill thing of I don't need the $signs, but if I put them in, then my copying down, it doesn't change, and I can change my function. I can do the quartile function. Let me do the inclusive quartile, and the quartile takes another property of whether you want the first or third or something. So I'll say the third quartile. So that's just a trick in formulas. And now I want to show you two graphs that are useful for statistical data, the box and whiskers and the why am I not thinking of the right word? Insert the histogram. There we go. So over here, we have a big set of things. This looks like a histogram, but that's not, sorry, this looks like a histogram, but it's not what you want. We can look at recommended charts, or we can go down here to see all the charts. And if you're on a Mac, you have to sort of figure out, I don't think Mac always has this little box down here. There's just another way to look in a Mac. So let's go here. Go to all charts. And one thing I want to show you is the box and whiskers. And the little X tells you where the average, the mean is. This line in the middle of the blue tells you where the median is. This lower line is the third quartile. This upper line is the third quartile. This down here, sorry, is the first quartile. Then this is the maximum. Unless there are outliers, it treats outliers separately, and down here is the minimum. So it's just a pictorial way of displaying a bunch of statistical information. It shows you the max and the min and the average and the median, and this measure of spread that tells us sort of where half the data falls in this blue area because it's between the first quartile and the third quartile. So that's just a simple little picture that is supposed to give you a lot of information about this spread of data. More information is in a histogram. So I highlight the data again, and I'm going to go to all the charts, and I'm going to choose the histogram this time. And for now, I'll just say okay. So here's the histogram showing ranges between 59 and 73. Here are the numbers that fall in that range. From 73 to 87, here are the numbers that fall in that range. So this sort of bins up the data, gives you ranges of data, and shows you how many samples were in that, how many, these were IQs, how many IQs were in there. We can right click down here and format the axis. And right now the bin width is 14. So that's a thing I can control. And I can say, I want it to be 15. 15 is in IQs, in the theory of IQs, 15 is maybe the standard deviation or something, but it's an important number. So maybe you want to force it to be 15. Or maybe that's something you can do here. Or maybe we can take the data and say, I want 8 bins. So that's some control Excel gives you over histograms. Now, there's another thing that we can't simply do, and that is in IQs, we associate names with particular ranges. So these people are gifted or something like that. Then we need to precisely control not only the width of the bins, but where they begin. With this simple histogram chart that Excel gives you, you don't have that control. We'll have to work harder for that. So for now, we have a histogram, and we'll just, whatever Excel gives us, we'll sort of accept, and maybe we'll do a little bit of modification here, either on the width or the number of bins. But when we really want to control it, we're going to have to work harder. And then we're going to have to sort of say, here are the categories that I want, and then I'm going to have to count for myself, and then I'm going to make, from my own counting, a histogram. And so later in the semester, I'm going to say, make a histogram, and you're going to have to decide which kind of histogram. Is it the quick, easy, just highlight the data, make the histogram? Or is it the, I have to grind it out and define my own categories type of histogram? Or sometimes I'll give you the data already binned up, and all you have to do is make a chart, a bar chart. So if I said, here was my range, here are all the people who have a normal IQ, and here are the people who are gifted, and here are the people who are genius, or whatever the categories are. I can give you that thing, all those things sort of pre-counted. If I give you those things pre-counted, you do not make a histogram. What you make when you're done will be a histogram. But if I gave you data, now I'm rambling on, but if I gave you data and said, here are the geniuses, here are the gifteds, here gifters, here are the above average, clearly not gifters, above average, here's average. If I said, here's the data, we had 1 genius and 3 gifted and 15 above average and 57 averages and below average. If I had something like this, 17, okay. If I had this data, I would not say histogram. I would say make a bar chart. That bar chart happens to be a histogram. I probably want to change the order of these and have the low first and the high later. But when I make this chart in Excel, I don't say histogram, even though when I'm done, I would call this thing a histogram when I'm done, but I don't use what Excel calls a histogram. Because if you do the counting, or somebody's done the counting for you, if the counting's been done, you don't say histogram in Excel. Because if you say histogram in Excel, it's going to do the counting for you. If I took this data and I made a histogram, if I just said, go here, not there, go here, and choose a histogram, it gives you something sort of crazy. That doesn't look like a histogram at all. Because it came in here and Excel decided to do the counting itself. And I already done the counting, so it didn't make sense. So this doesn't make sense. This makes sense. So here's, if I just want Excel to sort of pick the categories for me, I can just choose, highlight all the data, let Excel do the counting and do it. If somebody's counted for me, or if I have to do my own counting, then I make a bar chart. And when I'm done, I call that bar chart a histogram. So that will be a subtlety that will be coming up. And that's enough of me rattling on. Anything you want me to go over for the recording? All right. So I will stop recording and just start walking around and answering questions.